Okay, so just going over some terms on this circle. You do have to memorize it for your quiz on Friday. So arc is just any part. I can have an arc here, I can have an arc here, I can have an arc here. Circumference is, as we know already, perimeter of a circle. So this whole circle. Radius, right here, which is from your radius to any point on your circumference. And then diameter is right across the middle. That whole thing is your diameter. So these terms are nothing new. Secant. Secant is this line here. Okay. And then a chord is this one right here. What's the difference between a chord and a secant? Max?
Chord is, secant is a straight line that goes like forward.
Okay.
But then chord is just a line segment.
Right. Okay, good. So a secant cuts through. A chord has endpoints on the circumference. So I could have another chord right here. Chord is a big one. When you get into grade 10, you guys do a lot with chords. Okay, so keep that in mind. That's one of the most important terms. Tangent. Tangent line is this one. It also goes on forever, but what's different is this one cuts through your circle. This one, only one point touches your circle. Okay, so it's on the outside and only one point touches the circle. Central angle, inscribed angle. Yeah, let's. So I have all these definitions here. Again, I won't ask you guys for the definition on the quiz, but I will ask you guys to label, and you need to know the name so that you know how to apply it. I'm just gonna go to page 10 really quickly to go over these two terms. Okay, inscribed angle and what was the other one? In central angle and inscribed angle. Right, so inscribed angle are these ones right here. Right, so if AB is my arc, wherever you go to the other point on to a point on the circumference, all the angles that it makes are actually the same. So this is an inscribed angle. Arc AB makes this angle, which is an inscribed angle. Arc AB makes this angle, which is also another inscribed angle. So all these inscribed angles are equal. Okay. So for example, right here, if my arc is the diameter, then the inscribed angle is this right here, which is 90 degrees. Okay. And central angle. Central angle is same idea, but going to the center. Okay, and it's not called center angle. I have seen it so many times on the on the quiz, on the test. There's no such thing as center angle. It's central. Okay, so central angle is the one that goes to the center. And what's the relationship between them is that it's double your inscribed. Okay, so for example, if your inscribed angle is 90, what is my central angle here then? Angelina? 180, right? And as you guys know, it's a straight line is always 180. Okay. And if I say this inscribed angle is 40 degrees, how much is this one? How much is this one? 40, right? All the inscribed angles bounded by the same arc is equal. Okay, so those are all the terms that you need to know. Let's go over. Actually, let's just go over this. This. What is this called? Huh? Chord. Right, chord. What is this called? Radius. What is this called? Weak. What is this angle called? Central. All right, this is my arc. It's a arc AB, and it goes to the center. So this is my central angle. Okay. Okay, what would this angle be called? Yep, inscribe. Okay, if my central angle is 80 degrees, if central this right here, if this is 80, what is my inscribed angle? 40. Good job. Okay. What about okay, what is this one right here? Inscribe, and it's 40. Yeah. Okay. Yeah. Okay, good. So if I give you something like this on the quiz, easy marks? Okay. Let's do some examples right here. Page 7. Page 7. Doing circle properties. Okay, one of the property is that if AB is the tangent, which, sorry, let me see. Okay, okay. If one of the property is that if AB is the tangent line, and this is my radius, your radius and tangent always makes a 90-degree angle. Always, always, always. Yeah, it's actually called the tangent radius property. There's actual name. So if I know that angle right there, angle A is 90 degrees, what is the measure of OBA? OBA, what does it, why are there 3 letters? What am I actually asking? Which angle am I trying to solve for? Sorry? B, right. So when you see 3 letters, it's always the middle one. I drew a horrible angle arrow. Okay, it's always just the middle one that you're actually solving for. So OBA means OBA. So if you're tracing it, that's how you know which angle you're solving for. So this one right here. And so what is angle B? Emmy, what did you get? 27. How did you get 27? Because all angles should equal to 1 angle. Right, yeah. So if you do that, angle B is 27 degrees. Sorry. Okay. So what's the purpose of writing 3 letters like this? Why can't I just say angle B? Okay, so if I have a diagram something like this, okay, A, B, C, A, D, E, something like that, okay, angle B could have been this, could have been this, and it could have been this, right? It could have been all 3. So when you say angle ABC, I know I'm referring to this one. If I say angle CBD, then I know I'm referring to this one. If I say angle DBE, then I know I'm referring to this one. Okay? So that's why sometimes we would use 3 letters rather than just 1 letter. Yep. Does it matter the order of the other 2? Like, oh no. EBD the same thing as DBE? Yes. Right. It's just so EBD is the same as DBE. because it's the same in the middle angle. Okay, good question. Okay, example 2. So the point is O is the center of the circle, CD is the tangent. If CD is 15 and OD is 20, are we talking about angles here? No, we're talking about the length. Good. Determine the length of the radius. Okay. So, who has an idea? Pythagorean theorem. That's right, because this angle right here is a right angle. Good. So then Pythagorean theorem, which side is my hypotenuse? OD, right. Okay, so the 20 right here is my hypotenuse. So that means I'm solving for my radius right here. I'm going to do the subtraction one since I'm given the radius. So 20 squared minus 15 squared. Round to one decimal place. 400 minus 15 times 15, 175. So radius is about 13.2. Again, on the quiz, I will say what to round to. So usually one decimal place. Full marks? Centimeter. Okay, and not degrees. Okay, if you write degrees, you're gonna get half a mark off because it's the wrong unit. You weren't solving for an angle, you were solving for a length. And I've seen it on the test. I've seen it so many times that when I say 20 cents, like let's say if I didn't give you guys this diagram and I just give you this, I've seen people write 20 centimeters in the corner right there. Not good, okay? Remember it's length and angle. Okay. This one, an airplane is cruising at an altitude of 9,000 meters. The cross section of the Earth is a circle with radius approximately 6,400 kilometers. A passenger wonders how far she is from the point H on the horizon as she sees outside the window. Calculate this distance to the nearest kilometer. Okay, so what's the very first thing that you picked up here? The plane, okay. The plane is flying high. Okay. What's my very first step, Emmy? It's okay. I need to make a triangle. Good. Okay. We're trying to find a radius, right? Okay. Units are different. Okay. That's the very first thing you should pick up. Meters, kilometer. They want the answer in kilometer at the end, so let's change this up. What's 9,000 meters in kilometer? Yep. 9 kilometers. All right. And let's say you didn't pick that up. Does this look like it's longer than this? No. Okay, so you know that this cannot be 9,000. Right? So, okay, so Emmy said it's not a triangle. Let's make a triangle. Where can I make a triangle? How do I make my triangle? Okay, good. Thank you. From H to Earth. And what is angle H? 90 degrees because HA is my tangent and H Earth is the radius. So I know that's 90. And whenever we see a right angle triangle, it should be automatic now Pythagorean theorem. But I only have one length. How do I do Pythagorean theorem with one length? Do I know the other length? Yes, I do know.
Yes, you do. Yeah.
Where? What is it? What is the other length?
The radius is approximately 2,000.
It is.
Oh yeah, it is. Yeah.
It is. Why?
Because from the circumference of the arc to the Earth is 6,400.
Right. So they actually gave you the radius right here. Remember, your radius is the same throughout your circle. So if you know this is 6,400, that means this is also 6,400. 400. Okay, so there we go. We have our three numbers, Pythagorean theorem. I am looking for this HA. So I am doing the subtraction. So 6,409 square, take away 6,400 square. So the length of HA is, let me zoom this out. Okay, 6,409 times 6,409. Take away 6,400, and then square root it. I get the length of HA to be roughly about 330. Oh, what do I round this to? One decimal place. If it's one decimal place, it's going to be 0.5, right? 339.5. What's my unit? Kilometers. Okay. If I say to round this to the nearest whole number, what would this be? 340, right? Because this is a 5, so you round up, so that it becomes 340. Okay. So we do this tangent radius property a lot because it makes a 90-degree angle. And then once we have that 90-degree angle, we know we do Pythagorean theorem. All right, example 4. Point O is the center of the circle with line segment OC, bisect chord AB. All right, what does bisect mean? Bisect. You're gonna do a lot of like you did bisecting in science. It kind of means the same thing, but in grade 10 you also do a bisecting chords, bisecting tangents, bisecting everything. What cut in half, right? So cut in half, that means this is equal to this. Okay, cutting in half. So if OAC, if this angle is 33, okay, what is the angle X right here? What is angle X? 33 degrees. But why? They look the same. More mathematically. Margaret? How do you know? The length the same, yeah. It's not because these two are equal though. Even though you're bisecting. Same radius. So what triangle does this make? Jasmine? No, this doesn't. Does it make 90? If you bisect a chord, yeah, it actually does. Yeah, it's actually one of the property that you'll learn. Yeah, it actually does make a 90-degree angle. But more importantly, as Furhan said, what is OA? The radius. What about OB? The radius. Radius is the same for your whole triangle. So this is an isosceles triangle. Right? So not so much about these two lines being equal, but it's because this whole triangle is an isosceles triangle. Right? So then what's y? Since Jasmine said that this angle is 90 degrees, so y is 40. Hi. 180 minus 90 minus 33. So what do you get? 57 what? Degrees. And we can say sum of triangle. Okay. All these questions that we're doing, I do put the reasoning in brackets because that's part of your justification. Okay. So on the test, if I ask you for like explain, I don't need a whole paragraph. I just need some sort of justification. Hey, using the Pythagorean theorem in a circle, point O is the center of the circle. AB is the diameter with 26. Uh, CD is a chord that is 10 centimeters from the center of the circle. What is the length of chord CD? So chord chord CD. I want to find out how long this line is. Okay. I need ideas. Big brains. My big brains. Okay. Let's say, Max, you've been quiet today. Huh? Any ideas how I can start this question? I'm trying to look for CD, the length of CD. What about you, Alvin? Yeah, it's the chord. I need to find the length of that chord.
You can draw a line from O to D.
O to D, okay. How long is O to D?
So the radius is just 26 over 2.
Yep,
So it's 13.
good. Okay, because OB is 13, which means OD is also 13. Okay, so this is 13 right here.
Just use Pythagoras theorem.
Yeah. Pythagorean theorem again. Um, so 13 square, take away 10 square. So that is 169 minus 100 square root 69. You get 8.3 centimeters. What is 8.3 centimeters? What did I just solve? For him? For him? Half of the chord from E to D. So E to D is 8.3. Let me just rewrite this. E to D. This is how we also write the length. The length of ED is 8.3 centimeters. So the length of CD is 16.6. Final answer, Max? Centimeters. Because it's double. Okay, and why is it double? Because we just said if this OE bisects the chord, then they're equal. Okay, very last example. Solving problem using the property of a chord and its perpendicular bisector. Okay, so a horizontal pipe has a circular cross section with center at O. Its radius is 20 centimeters. Okay, so I see that. Water fills less than one half of the pipe. The surface of the water AB is 24 centimeters wide. So AB, this is 24. This is 24. Determine the maximum depth of the water, which is CD. Okay. Do I know how long AC is? How long is AC?
12.
12, yeah. Good. So I know this is 12. Okay.
OC.
Yeah, and then I can do Pythagorean theorem to find OC. So this is 20, this is 12. I can find OC. So 400, take away 144, square root that, I get 16. Wow, I get 16. Okay, so OC is 16, but how does that help me find CD? If you stop here on the quiz, you'll get 1 mark. You get me?
Because we know the radius is 20,
Mm-hmm.
so we can do 20 minus OC because
Yeah, you're on the right track.
we can do 20 minus 16, which is 1.
Yeah, but
because OD is like the radius.
right. Okay. Excellent. So OA is the same length. It doesn't look like it, but it is the same length as OD because they're both your radius, which is 20. So if you know that the OD is 20 and OC is 16, that means CD is just simply 20 minus 16, which is 4 centimeters in depth for the water. Okay, so we went through quite a bit about circle properties. What was the only math that you did like the whole morning? Pythagorean theorem. Is that hard? No, we did it last chapter. We're doing it this chapter. So the math itself is not hard. What's hard with these is analyzing the diagram, seeing what you're given, putting in the numbers in the diagram, and then solve. Okay, so the math itself is not hard. That's why you need to know the properties. Like let's say for example, if you didn't know the tangent radius property, you don't know that it makes a 90-degree angle. If you don't know the perpendicular bisector with a chord that makes a 90-degree, then you don't know that it's a 90-degree angle. All right. So let's just try a few questions on your own. Very little homework tonight. Just page 9. All right. So just some more practice. Page 9. I'm sure you guys will finish before the end of the class. And then tomorrow you guys will do page the on work on inscribe and central angles.